Good morning, everyone. My name is Arslan, and you are watching Proper Pariksha, the place where we strive for academic excellence in a simple and comprehensive manner. So, today we'll be starting the topic of area, or that is also called as region, and we will be discussing what are the different formulas for different types of standard shapes. So, first of all, I would like to inform you that I would like to remind you that for those who have not gone through the chapter of chapter 5, understanding elementary shapes, and those who have not gone through this chapter from beginning, please go through that so that you can understand the exercise 10.1 much more easily. Coming to the topic of the day, that is area. So what is area? Area is the amount of surface enclosed by a closed figure, and therefore it is called its area. For example, the region covered by a square. Okay, region covered by square. This is called the area of the square. Now coming to the first topic, first subtopic, that is area of rectangle. So we know what is a rectangle. From the chapter of understanding elementary shapes, we have noted down the various properties of the rectangle, and now we will be discussing the formula of area of rectangle. So if we talk about the area of rectangle, let us say this is L1 and this is L2, and these two are equal to each other and parallel to each other, and this is equal to this one and parallel to this one. Therefore L1 and L2 will suffice. This angle is always 90 degree, that the edges meet each other at 90 degrees. For example, I draw a triangle from here to here. What will be the case? That will come later on. Okay, so I'm just trying to remind you about something. So if we divide the rectangle into two triangles, we will get to the formula of a triangle. So before that, we first of all discuss the area of rectangle L1 and L2. So simple area of rectangle can be written as L1 into L2 or AB into BC. Area of a square. What is that called? Area of a square is most definitely L1 into L2, but L1 is equal to L2. L1 L2 into L2 is equal to area of rectangle, but L1 is equal to L2 is equal to L. Therefore, area of a square is equal to L square. Simple. Because square is a special case of a rectangle, therefore L1 putting equal to L2 putting equal to L, then we will write L into L is equal to area, that is L square. Area of a triangle, how do we come to that? So we can divide the rectangle into two triangles. For example, I have this rectangle and I will divide that into two rectangles, two triangles, sorry. This one is L1, L2. Similarly, this one will be L1 and this one will be L2. The angles are 90 degrees. Okay. So area of triangle is what? L1 L into L2. But for a triangle, we have divided it into two equal parts. That is 1 upon 2 and 1 upon 2. So for the area of triangle, we will multiply area of rectangle by 1 upon 2, and we will get the answer as 1 upon 2 into L1 into L2. Here we see that L1 can be written as the base of the triangle. If we talk about ABC, AB is the base of the triangle. AB is equal to base of the triangle, which can also be written as B. So it will be half into B, and L2 can be written as the height of the triangle. Therefore, BC is equal to H, or the height of the triangle. What is height? Height is the line drawn from the any of the sides to its opposite vertex, making sure that the line extended to the opposite vertex makes a 90-degree angle from its base. If we draw LBC, if we draw a line from AB to C with a 90-degree angle, it will coincide with the same line as that of BC, that is L2. Therefore, it will become H, and the formula finally will be half base into height. and this will be valid for all the triangles, be it like this or be this. So here A, B, C, if we take AB as the base, then we will extend AB, make a perpendicular line which will extend till C, and the height or the length of this extended line will be taken as the height, and we will multiply the formula half base into height, and we will get the answer. Coming to the area of rhombus. So for the properties of rhombus, if anyone could recall, what is the distinct property of rhombus? That all the sides are equal to each other, but the diagonals are not equal to each other. That is what? That is because of the compression or the expansion faced by the square on the adjacent vertices. Because it was compressed like this and expanded like this, it has become d1 is not equal to d2. This is the property of the rhombus. So for us to find out the area of rhombus, what we can do is that we can find the area of one of the triangle first. So let us name it A, B, C, D and O. So for triangle AOD, what we will see that area is equal to half, let us say OD is the base, half into OD into AO. And rhombus on the diagonals of the rhombus intersect at a 90-degree angle. Therefore, the height will be AO, and it will be written as half into OD will be, let us say, BD is equal to D2 and AC is equal to D1. Therefore, it will be D1 upon 2 into D2 upon 2, which will be further written as D1 d2 upon 8. Similarly, when you will find the area of a triangle AOB, you will find that the area comes same to same as d1 d2 upon 8. This means that after adding all the four triangles area, we will get the answer. Therefore, d1 d2 upon 8 will be multiplied 4 times, which will give us the answer of d1 d2 upon 2. Therefore, the answer will be half d1 multiplied by d2. That will be the area of the rhombus. Coming to area of the circle. What is the area of the circle? Before that, what is the perimeter of the circle? The perimeter of the circle is 2 pi r. Perimeter is 2 pi r, or it can be written as pi d, where r is the radius and d is the diameter. So d by 2 is equal to r. For the area, we just have to do pi r square. Or if we use d, what can we do? Pi d upon 2 square, that will give us pi d square upon 4. So either this formula can be used or this formula can be used. R is equal to d upon 2 will be remembered from now on, and P is equal to 2 pi r or pi d, or area is equal to pi r square or pi d square upon 4. What was the value of pi? 22 by 7 or equal to 3.14. So with this, we conclude the topic of areas of various standard shapes. And in the next video, we'll be dealing with certain examples which will allow us to understand more regarding how do we calculate the various areas of various standard shapes. So if you like this lecture, do hit the like button and subscribe to our channel. In case you have any suggestions, do comment in the comment section or connect with us on any of our social media platforms. Till the next time we meet, I bid you farewell. Goodbye.